course, waylaid. You can see I was trying to get the proper spelling of the past tense of waylaid. Sounds like Gary Oram might have been waylaid coming to lecture today. And Adam, I hope you're doing fine there, just kind of having a long weekend. And also, guys, there's a couple others. Drop into the course here. I think I had 4 or 5 students signed up, but as of now, I've only been seeing Gary and Adam in class. If and I apologize, I don't even know. Let's see who else in the class here. Well, I know Tim's dropping. So Micah, hopefully you're out there somewhere, and then Joe as well. Guys, let me know if you're coming to class. It'd be good to see you. Either way, we've been recording lectures, so you can catch up. It's not going to be that big a deal. So 3 things I want to cover today. One is to get into Lovins, as promised. I mentioned it's one of the optional textbooks. I've got a copy here. I think Adam was buying a copy. Gary, I don't know what your plans were for that, but I've also just photocopied or scanned the first couple of chapters, and that's what I want to go over today. First couple of chapters of Lovins. So Amory Lovins, I don't know if you've seen this guy or not. There's a YouTube video out there about him. Let's see if that plays. But interesting character. And what's kind of funny about it, he's so dang smart and forward-thinking, and the question or the test is, will the rest of us be able to catch up and hang with him? I think to a large extent, we've done that with previous technologies. Here we are servicing internal combustion engines, steam engines, things that one particularly clever individual came up with in the past, and then we've got their legacy. And what Lovins is doing is, as he says, fairly bold. There's the first word in the subtitle, Reinventing Fire, bold business solutions. So he has tried, and I think in a lot of ways succeeded. Well, we'll see if he succeeds later, to tie in energy with money. The subtitle is Bold Business Solutions for the New Energy Era. So business obviously tied very intimately with money, and then energy. When he says era, he means it. It's not just next year. It's the future of the planet, really. I mean, he might as well have said energy epoch. Epoch. Well, let's take a look at Lovins. Oh, and then the other 2 things I wanted to cover today. I want to cover Nash equilibrium theory a little bit. I think there's some pretty impressive thoughts in there. And then third, what I want to do was cover, just get a little draft going of the EPA grant. So we'll do 30 minutes of Lovins, 20-30 of Nash, and then 20-30 of the EPA grant. All right, three little chunks. So here we are, lecture 3. I'm just gonna edit this a little bit on the fly as we go. I didn't have so I've tried to just do week 1, lecture 1, week 2, lecture 2, week 1, lecture 3, or sorry, all 3 of those are week 1, lecture 1, 2, 3. Then I'll have 3 week 2s, lecture 1, 2, 3, and go from there. So right now, I still have a bunch of stuff from Kent Swift sitting here under topic 4, topic 5, 7. I think what I'll just do then is take this guy, edit it, and I'm going to call this week 2, lecture 1. And the first thing we're going to be doing is Lovins, chapter 1 and 2. Second thing is going to be Nash paper, and then third thing is EPA P3 draft. There we go. Save changes. And I've got this guy way at the bottom. And I'm going to turn it on and try to drag it way up here. Let's see if it works. You guys get to see the first-hand view of how fantastic it is to work with Moodle from the instructor's side. Oh, so pleasurable. Oh, so pleasurable. So there goes topic 5, there goes topic 4. We're just going to put it right. Well, let's just put it way up here. See where it ended up. Oh, not too bad. There we go. Okay. Week 2, Lecture 1, Lovins, Chapter 1 and 2, Nash paper, and then finally the EPA P3 grant. So let's see if we can actually bring up the Lovins texts. I had these scanned a couple of years ago, just in case you didn't want to buy the book. I think as we get further into the book, I'm not going to be able. I can't scan the whole thing legally. I apologize. It's in black and white. But, okay, so chapter 1 is just called defossilizing, and when you look at how quickly we've been burning through our fossil fuels, I think he's got a. Oh yeah, this figure is so telling. So this is looking at the beginning, essentially, of the Industrial Revolution began a little bit before that. A lot of people say with the cotton gin, when mechanized, sort of mechanized labor, I guess you'd call it, rather than manual labor. But it's not really until kind of middle of the 1800s, and then in the 1900s, and certainly into the 2000s, we're right here, that we see the tremendous takeoff of the consumption of fossil fuels. Now, if you look down here, you can see that this entire vast mountain of fossil fuels that we're consuming is just this little blip on the radar screen. And so what he's got here is the year 2000, the year 1000, and sort of going back to the year 0 BCE. I mean, there's just nothing in terms of fossil fuels. We just don't have the technology to take it out, and then all of a sudden, here it is. And if you were to project this even further back in time, you'd come up with that. You'd come up with that 10 million to 1 ratio that we do in NRG 101, where the width of this little Gaussian right here is just 1/10,000,000th of the history of life on Earth. So we've got 300 years of consumption basically, and we're right in the middle of it, versus the 3 billion years of deposits. So 10 million to 1 ratio. Whereas if you just kind of look at it on this scale, 300 divided by 3,000, it's just a 10 to 1 ratio. This little blip occupies 1/10 of this, of what you might just call recorded history. Roughly speaking, 1/10 of recorded history. All right. So what else does Lovins have to tell us? Oh, another thing he talks about, and I think this is a little earlier in the this is in chapter 1. Yeah, it's right here. This Anthropocene era, or the era of man. So we've sort of left the Holocene and are now creating our own habitat to a large extent, either intentionally or not. A few other things here. $39 billion. You know, a lot of times people will complain about renewable energy getting subsidized, but if you look at the subsidies to the oil industries, it says in 2006, federal subsidies to oil and gas, mostly oil, totaled about $39 billion. So shifting several $1 billion a barrel from pump prices to income taxes, which it's kind of strange, you know, in a capitalistic society that we would be, taxing ourselves across the board to reduce the price at the pump. Maybe it makes sense, you know, if in fact the wealthier people were paying more, you know, so that to keep poorer people out of so-called energy poverty, where you're spending an inordinate amount of your money on energy, or a larger fraction. And that's, I mean, shoot, that's going to be true no matter what the case is, that, the poorer you are, the less money you have, the greater fraction of your income you're going to be spending on, basic survival or subsistence, staying warm, staying cool, staying fed, staying clean. So that's a real issue. A little bit of a digression there, but you look at the fossil fuel industry and say, gosh, do they really need a subsidy? Do you do it on the I guess the so-called back end, the supply side? Do you give them money so that it's cheaper for them to deliver and pass that savings along to the consumer who might not be able to afford it? Or is it better to give that consumer some kind of fuel stamp, or the equivalent of a food stamp for fuel? I don't know, big questions. I don't have the answers, but anyway, $39 billion going to the fossil fuel industry, 2006, and probably similar now as well. All right, going on to the next figure here. What we're looking at, cost of oil dependence to the U.S. economy. So there are three curves here. The top one is called wealth transfer. So this is just money that we send out of the country to give to people that sit atop the oil and to some extent refine it. This middle one, dislocation losses, these are price shocks. So cost associated with artificial shortages. And then finally down here, this is just plain out gouging. So companies that or filling stations that can jack up the price artificially. And I guess I don't see a problem with that. I mean, if you've got something that people want and they're willing to pay it, why not just take on the full capitalistic model and buy it and go ahead and gouge, I suppose. Where was I going with that? I can't remember where I was going with that. But one challenge, and we'll see this here when we get into the second chapter, is the only way to prevent this is to provide some kind of alternative, right? And so already, what are your alternatives? Well, you could walk, you could ride your bike, but then you get into the whole time issue, and we haven't even started talking about the fact that time itself is worth money. And anyone who's working a job is getting paid a certain amount of dollars per hour, pennies per minute, however you want to look at it. So to avoid issues like this, you really have to become a better master of space and time and material transport than your neighbor, or you're subject to these fluctuations. I'm not sure if I explained that the best, but There it is anyway. Okay, next one. I love this quote. It's just bizarre. It says, "The United States has diverse interests at stake in the Middle East, of course, but it surely wouldn't have sent 500,000 troops to Kuwait in 1991 if Kuwait just grew broccoli." Well, there might be some broccoli fans out there that would disagree, but the reason we went there was to protect the oil fields from an Iraqi invasion. Okay, a couple other things on the question that you'll see on your quiz. I'm not going to have to hit all of them. You'll see them. What else? Let's look into some of these figures. So you will see a tremendous number of figures, just like the ones you see here throughout Lovins. Right now, I'm just looking at figure 114, and we all know what primary energy is from NRG 101, and you can see they're laid out here. There's oil, there's natural gas, there's coal, there's nuclear, and then then you go biomass, then you've got hydro, then you have other renewables. So we here in the Energy Technology Program are really out on the bleeding edge of this. We were sort of trying to get beyond this massive bit of oil, gas, and coal, and really focus on expanding these other renewables. Now, what they're showing below here is where it goes. So, transportation, buildings, and industry. Now I'm finally seeing what our friend Amory Lovins is doing. Okay, so, and you're not going to be able to see it all in this figure, but oil is this, dark brown. Coal is this light brown. Natural gas is the blue. So you can see in the transportation industry, so there's 4 sectors, and you can think of them as BITE, the way I've been thinking of them as BITE. So buildings for B, industry for I, T for transportation, and then E for electricity. So if we look right here, you can see most of this dark brown is going to transportation. There's a little bit of blue there and a little bit of biomass, and this is the so-called end-use energy. And you can also see that it's about 2/3, and actually that's not too bad. When you look at it, let's see here. I'm just trying to figure out where hydro. Gosh, it's funny. I don't even see. I'm looking for the light green of other renewables and the light blue for natural or for hydro, and I don't see either one of them on this this so-called BITE map. What I do see is that electricity is just a subset of buildings, and it's here in industry too. It's that yellow. There's really no electricity in transportation, and there's also no hydro or other renewables in any of the 3. And you'd think it would show up as a sliver, and it might just be that it's showing up in one of these little tiny cracks, in one of these little white, I shouldn't say cracks, in one of these little white dividers, one of these little white line dividers. All right. Well, that's what we looked like in 2010. Now, here's the business as usual energy consumption in 2050. You can see that other renewables definitely expanded. Hydro went down just a little bit. Biomass expanded. Nuclear shrinks significantly. Coal might expand a little, but not that much. Natural gas expands a little, and oil actually shrinks, because in 2050 we're well past peak oil. Okay, and then the end use, the efficiency isn't really any different. 176 to 117 is about the same as 61 to 93. That's the business as usual. But then if you get into the reinventing fire, as Levin's called it, you could actually get less primary energy consumption, less end-use energy, but presumably the same amount of comfort, right? So just being a little smarter with the efficiency, more or less, of how you're using these things. And what do we see? We see that other renewables have expanded tremendously. There's almost no oil usage, fair amount of natural gas, almost no coal whatsoever. Hydrogen finally comes online. Biomass expands significantly, and hydro plays about the same part. We've pretty much tapped all the hydro on the planet. All right, so that's just showing what these graphs are made of. You'll see a lot of those throughout the book. All right. The next, this is a pretty impressive number here. You say we can reinvent the fire that now burns in our internal combustion engines as well as in our buildings and factories, eliminating oil by 2050, all while saving about $5 trillion. And this is going to be across these sectors, right? So buildings, industry, transportation, and electricity, saving $5 trillion. And presumably, you're going to spend that $5 trillion on something else. Name your favorite thing, and that's what you're going to spend your money on instead of the boring stuff that we're talking about now. Okay, so that's chapter 1. Let's take a look at chapter 2. Maybe. All right, that's good. So that was one little PDF. Let's take a look at chapter 2. And so he starts out with the T in bytes. So this is transportation, and the subtitle is Fitter Vehicles Smarter Use. And I'll just read a couple little things from the chapter highlights. It says the goal in 2050, super efficient autos, trucks, and planes, far more productively used, need 3/4 less fuel and no oil, and have less life cycle cost than the vehicles of today. Yet they provide 90% more automobile miles, so people are driving further, 118% more truck miles, things are still being shipped, and 61% more airplane seat miles with uncompromised convenience, safety, and performance. So there's a lot of engineering to go on here if we are to actually do this. Why am I looking at it that way? Levin's chapter 2. Why this is so big. It looks like I didn't quite get the entire chapter. And why is it splitting over 2 pages like that? Well, we'll make it work. Okay, and then the next highlight says the business opportunity. Radical efficiency enables alternative propulsion fuels, transforming vehicle manufacturing for breakthrough competitive advantage, while customers save money and mobility options expand. Society eliminates oil dependence, reducing many security and business risks. I like that. I like that one a lot. The bottom line, oil not needed saves $3.8 trillion in 2010 net present value. So there's $3.8 trillion that we did not spend on oil. Fun. Sounds fun. Okay, business sectors that can profit. Vehicle manufacturers and suppliers, chemical and electronics industries, fleet operators, entrepreneurs, good, real estate developers, nice, good for Missoula, electric utilities, farmers, and foresters. So the farmers are more than likely making the ethanol, and the foresters are making the lignified fuels. Policy enablers. Innovative state, regional, and federal policies can remove barriers to buying super efficient vehicles and using them in smarter ways without new federal taxes, subsidies, mandates, or laws, with a minor exception about truck weight limits. Okay, so we might have something to say there, because we're still going to have to shift things around. All right, okay, so this is the first full set of pages. And I'm not going to go into this in much detail because I want to wrap this up in the next 3 minutes. So I'm just going to kind of flip through here. We're looking at expanded use. So here's 2010. He breaks down the oil combustion, and all of this here is transportation. There's a little bit of oil combustion in industrial, so buildings and making a little bit of electricity. So here's industry, here's keeping buildings warm, and here's a little bit of oil for making electricity. By 2050, we're going to go from 17, and this is million barrels per day. God, it's amazing. No, it's not. There's a lot of people in the world. There it is. Okay, then the next figure, what he's looking at is U.S. autos fuel economy use and occupancy and distance traveled in the past. So here's gasoline consumption, this little dotted line right here, miles driven per year. You can see this little dip in 2008. Fuel economy of new autos. So this is also kind of bumped around. And what's bizarre to me is it just doesn't keep going up. I don't really understand it. Why people would not go for more efficient vehicles all the time. Okay, and then finally, this one is average occupants per auto, and this number looks kind of weird because it looks like you're at 1 in 1975, and now there are only 0.8 per auto now. Well, what that means is if there were 2 occupants per vehicle in 75, there are now 1.6 on average. And so that's actually gone down, kind of bizarrely enough. But went up just a little bit here. What else? He talks a lot about the materials going into cars, how you can actually make them a lot lighter. And if they're going to do that, then you kind of have to have other vehicles on the road playing by the same rules, or else even though these things are kind of light, they're perhaps more prone to injury of the occupants. Here's a shot of Volkswagen's concept car, plug-in hybrid, little diesel engine, 27 horsepower electric motor. The drag coefficient is 0.186. That's amazing. It's hard to get up much under 0.3. And then looks at automobile fuel savings. So here's our 2010 demand. Here's no efficiency 2050 demand. But if the what's EIA stand for? Energy. I always blank on that one. EIA. Energy Information Administration. So if the EIA prediction is correct, then we won't have the business as usual, and we actually will have more efficiency. That's sort of where this negative comes from. So then you could call this the business as usual demand, this fourth bar, and then if vehicles become fitter, This is the reinventing fire scenario. And then more electric, you'll just have this little tiny amount of fuel use. So this last bar is the amount that Lovins thinks we can actually consume, 0.4 million barrels per day instead of 8.8 or even up to 15. It's got another figure on carbon fiber manufacturing cost reduction. So he's got the fixed cost. This is of your plant. Variable cost. This is making the plant more or less efficient, and the materials are going to cost something as well. This is steel, first of all. Carbon fiber is more expensive. The material is just more. There's not just carbon fiber sitting around the way there is iron. There's plenty of carbon, but it's a lot more engineering goes into making these fibers. A lot more surface area. It still has to get hot, but the processing is much more complicated. If we can reduce that, carbon fiber cost reduction potential at $5 a pound, making the powertrain smaller, and then it just says other system benefits associated with carbon fiber, we can get down to the point where carbon is competitive with steel. Okay, talks about Elon Musk a little bit in here, Tesla, BMW's battery electric car, Asian competitors. What else am I looking at? Oh yeah, I want to look at this. And then biofuel supply on page 67. Yeah, I kind of skipped ahead a little bit here into the chapter. But if you look at biofuels as opposed to oil, so let's see here. So again, this is our 2010 demand. Here's the frozen efficiency again, forecast savings, autos becoming more efficient, trucks, remaining sectors. The reinventing fire demand is down around 1.3. Now, if biofuels come online, what we're looking at, and here's where he shows his little break even. This is million barrels per day equivalent. If we can make all of this 3.1, we can make it from agricultural waste, mill residue, dedicated energy crops. You've also got municipal solid waste and forestry residue, which would come online and actually produce more than the 3.1 that's sitting right here. So what Lovins is saying is if we get more efficient and drop into some biofuels, then we won't need oil at all. All right. Well, I'm gonna cap it right there. We're looking at 30 minutes or so. I think that's about enough time for everyone to pay attention. Two more. Maybe one more. Let's take a look here. Finish off the chapter. Oh, yeah. So here's your zeroing out oil by 2050 plot. And then I really like this poster a lot. It's, well, let's see, second to last. I guess I skipped a page. I skipped page 73. Yeah, 73 is not on here. 72 and 73 I ended up skipping. But there are recommendations for key factors. So there's the no regrets, the opportunistic, and the innovative. And these are things that, you know, if you're a business person, you look at the innovative. What do I do to make a buck in the automotive industry in the next 4 decades? And a lot of it revolves around efficient vehicles. This is also kind of a neat little poster, and this is just efficient use of space. So here's a road full of cars, each person sitting in their car. Here's the same road with the same people without the cars, showing the use of space. Here are those same people standing where their cars would be. Here's everybody squished into one bus. Here's the bus itself. And here's everybody on their bikes instead of in their cars. This is everyone on their bikes using the space, in a close riding formation here in the lower left. And then finally you have everyone walking and showing that every single person that was kind of clogging the street in their car could have just been walking on the sidewalk with no need for the road whatsoever. So clever, Amory. All right, with that, I'm gonna put a fork in Levin's chapters 1 and 2 and get on to some Nash.